Let's understand what is a normal force. This is the definition here. A normal force is the perpendicular force exerted by a surface on an object in contact with it. But let's elaborate it. Let's say ranale a line in this way. Let's say this is line AB. And then now let's draw a normal line. A normal line actually a line it will create 90 degrees with this line here AB. Our normal line it will be in this way. Or create 90 degrees. And then a line in this way. A normal line here it will be in this way. Or create 90 degrees. So the moment we go the weight normal force, the weight normal in creating 90 degrees. So now let's understand what exactly is a normal force. Let's say an object yellow ray is on the surface, and then let's say this object in a mass 10 kilograms. For the reason this object in a mass you a weight force, because any object in a mass it experience a force of gravity. Remember, force of gravity always it brings the object downwards. This object in a weight, and then we calculate as W mg, whereby this G is 9.8 and then this M is mass. So now an object is on the surface. What we know a normal force is always perpendicular to the surface. This is our surface. A 90 degrees. The normal force you upwards. So the normal force you act in this direction. But now what is important to this object is not going up or down. Normal force our weight. Let's find this weight. Mornali mass 10 kilograms. So 10 times 9.8 and then 98 newtons. So le normal force yarna it will 98 newtons. Let's understand why. This object is not going up or going down. The upward and the downward forces are balanced. Let's see for an example. Let's say mornale two people. And then let's say they're pushing against each other. Let's say we're pushing. This one push in this direction, and then this one push in the other direction, the opposite direction. This person will apply force 50 newtons, and then this one will apply force 50 newtons. These people they will remain in the same place. This person I can see on the left, and then even this one I can see on the right, because banally the forces are so they are balanced. So it means the horizontal forces are balanced. But now this situation. Now normal force act vertically. And then a downward force, which is a weight. For the reason this object the upward and the downward forces are balanced. So only a situation like this one where an object is on the surface, and then that object in a mass, and then questionnaire calculate the normal force. All that you can do on calculate your weight, and then what's about your weight a normal force. So that's all about the normal force. A normal force actually a force is always perpendicular to the surface. I'll level this example. This questionnaire, an object of mass 10 kilograms rests on a flat horizontal surface with a horizontal force applied. Mornally, an object is on the horizontal surface. And then in a le mass wa 10 kilograms. And then more this object by a certain force. This object in a mass, re expect a force of gravity is pulling this object downwards. So more a weight force, which is W mg. And then what we know always a normal force it will act perpendicularly to the direction of motion, because this is the surface. The normal force over in this direction because it's going to create a 90 degrees. So our normal force over in this way. And then now we're going to calculate the normal force. But first, let's answer this part A. Draw a free body diagram showing all forces acting on an object. Actually, a free body diagram is a way of representing all forces that are acting on the object. Re draw a free body diagram, re shumisha a dot. But re is a force diagram, re shumisha a box. This dot represents this 10 kilogram object. So now we're going to draw the forces still already actor here. Arnali force applied, and then our force applied is in this direction, key this one. And then rename our key force applied. And then arnali a force of gravity, which is always downwards. Or you can say weight, it's all the same thing. And then arnali a normal force. So this is our free body diagram. Relo requesting a draw a force diagram. Rebortodi are the same thing, mara instead of using the dot, vertlo shumisha this box. Rela or revertable something like. So this is our free body diagram. Rawonchije all forces still already act on this object. Ranali normal force, ranali force of gravity, and then ranali force applied. So this is our answer for part A, and then our level part B. Part B calculate the magnitude of the normal force. What we know for the reason this object normal force the weight. Fn the weight. So remember W mg. So to find the normal force, get 10 and then carry times 9.8. So our answer is 98 newtons. This one is an object of mass 10 kilograms is on a flat horizontal surface and is pulled by a force of 100 newtons at an angle of 30 degrees. More than a different situation compared to the previous example. But first, a level part A question. Draw a free body diagram showing all the forces acting on an object. Arnali a downward force, which is the gravity. And then arnali a normal force, which is always perpendicular to the surface, because this object here in this direction. Remember just because by at an angle, it doesn't mean because loena really in a shopping or drolly in this direction, but it doesn't mean your drolly will go upwards. Your drolly will go in the direction here we are going. So our normal force will be upwards because of this surface. And then now level of force applied your force applied now is not in this direction, but now your force applied is in this direction. So this is our force applied, and then this is our free body diagram. So now our level the next question. Part B calculate the magnitude of the normal force. On the previous example, re be re na le a situation whereby an object is being pulled in this direction, and then re be re na le a normal force which is upward, and then re na le the force of gravity which is downward. O ka lemoga gore re be re na le only two vertical forces, which is the normal force and the force of gravity. This is because this object, it was being pulled horizontally. But now more na le a different situation, because now our object is being pulled at an angle. The moment the object is being pulled at an angle, re la gore re tlo ba le the components. This force applied e creator the components. Re na le the vertical component, and then ra ba le the horizontal component mo e le gore is acting in the x direction. So now see something. Re la gore for this situation re na le a normal force which is upward, because this object here in this direction, and then re na le the downward force which is the gravity, because this object in a le mass. So now because more na le a component, and then this component le yona is an upward force, re la gore now for this situation re na le a normal force that is going up, and then ra ba le the vertical force, and then ra ba le a downward force. So re la gore now for this situation re tlo dira the same, ra re the upward forces ke these two forces di lekana le a downward force. Re la gore re tlo ingwala in this way, ke tlo re Fn plus Fv ke these two forces because they are together going upwards, and then ka re di lekana le the downward force which is mg. So now re la gore our formula it tlo ba in this way. So always o tlo tshwanela gore o tsebe gore ge le gore an object is being pulled at an angle, re na le two forces that are going upwards, re na le the component, and then ra ba le a normal force. So re la gore always o tlo shumisha this formula ya Fn plus Fv e lekana le mg. And then now because re nyaka go calculate Fn, re la gore ke tlo re Fn e lekana le mg minus Fv, because ke tšea Fv ka iša to the other side, and then ya change sign. But lemoga gore ga re ne Fv, but it's easy to calculate Fv because re tlo shumisha this right angle triangle. Re la gore I can say sin theta e lekana le opposite which is Fv, and then over hypotenuse. Remember gore ba re file gore this object force ya yona ke 100 newtons, so re la gore our hypotenuse it will be 100 newtons, and then from there re la gore finding Fv nka cross multiplier, and then ka re sin theta times 100. So re la gore now ke tseba Fv, re la gore now I can go there and substitute. So for mg mass re na le gore ke 10, and then our g is 9.8, and then minus Fv ya rena ke sin theta times 100, and then sin our theta ke 30 degrees, and then times 100. From there re la gore ro kry-a 98 minus this part it will fa gore ke 50, so 98 minus 50 re la gore ke 48. So re la gore our normal force ke 48 newtons. So this is our answer. So what is important or always re le gore an object is being pulled at an angle, this is our formula, and then o ka kgona go tseba gore this formula e tswelela kae. This is because for upward forces re na le Fv and re na le Fn. So that's it for this problem. This one here, an object of mass 10 kg rests on a flat horizontal surface and is pushed by a force of 100 newtons at an angle of 30 degrees. More than a different example, because now our object is being pushed at an angle, but as for the previous one, it was being pulled at an angle. So our level part A question. Draw a free body diagram showing all the forces acting on an object. Arnale a downward force, which is gravity, and then arnale an upward force, which is a normal force. Remember, a normal force is always perpendicular to the surface. Just because this object may push in this direction doesn't mean our object here in this direction. It means the object here in this direction. Because when I push a grade, it doesn't mean your grade will go downwards. Your grade will go in this direction. So if this is our surface, to create 90 degrees, an upward line. So that is why our normal force is upward. But now let's see the force applied. Our force applied now is in this direction. So this is our force applied. Yeah, the previous one, our force applied in this direction because the object, it was pulled, but now it's being pushed. So that is why it's in this direction. So this is our free body diagram for part A question. Our level part B question. Part B question, calculate the magnitude of the normal force. But now can you go something? This object is being pushed downward. This force, the components, for the vertical component, downward because this object is being pushed downward. So now, this situation, a gravity which is downward, and then the component FV which is also downward, but the normal force is upward. But apply the same thing. For the reason this object is not going up or down, the upward forces and the downward forces are equal. So now Fn Fg plus Fv, because our downward forces these two, and then upward force one. So from there we can substitute. So Fg mg, and then Fv, remember sine theta opposite, our opposite Fv, and then our hypotenuse this force 100. So from there your Fv sine theta times 100. So more sine theta times 100. And then now let's plug 10 and then times 9.8, and then sine 30 degrees times 100, and then 10 times 9.8 for 98, and then this one for 50. Our answer to create 148 newtons. So this is our normal force. So an object is being pulled and being pushed, a very slight different. So this formula always an object is being pushed at an angle. So that's it for this question.